Section 4.1 Related Rates. If we are pumping air into a balloon, both the volume and the radius of the balloon are increasing, and the rates of increase are related to each other. But it is much easier to measure directly the rate of increase of the volume than the rate of increase of the radius. In a related rates problem, the idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity, which may be more easily measured. The procedure is to find an equation that relates the two quantities and then use the chain rule to differentiate both sides with respect to time. So for example 1, inflating a balloon. Air is being pumped into a spherical balloon so that its volume increases at a rate of 100 cubic centimeters per second. How fast is the radius of the balloon increasing when the diameter is 50 centimeters? Okay, so let's write out the things that we do know. Okay, we can see that the volume is increasing at a rate of 100 cubic centimeters per second. So that's dV of dt, since that is the rate, and that's going to equal 100 cubic centimeters per second. Okay, and then we also know the diameter is 50 centimeters. So if we wanted to find the radius, then we would take half the diameter. So that would be 50 divided by 2, which would give us then 25 centimeters. So now we know what the rate is, and we know what the radius is. So since we're dealing with a spherical balloon and we're talking about the volume, that means we're going to be dealing with the formula for the volume of a sphere. So the volume of a sphere is 4/3 pi r cubed. So now we're going to take the derivative of v with respect to t on the left side, and on the right side we're going to take the derivative of r with respect to t. So what happens here is when we take the derivative on the left side, we get dv over dt, and then the derivative here is 3 times 4/3. This is going to give us 4 pi r squared times the derivative of r with respect to t. So our goal in this equation now is we want to find dr over dt. We're going to isolate that, and so we're going to use the given information. So we know that dv over dt is going to equal 100, and that's equal to 4 pi, and we know that r represents 25 centimeters, and we're going to square that times dr over dt. And so now what we want to do is we're going to divide both sides by 4 pi times 25 squared, 4 pi times 25 squared. So we end up getting 100, and 4 pi times 25 squared is going to give us 2500 pi, and then that's going to equal dr over dt. And so therefore, if we want to solve here, we know that dr over dt is going to reduce to 1 over 25 pi, which is equal to 0.0127 centimeters per second. And so we wanted to find out how fast is the radius of the balloon increasing when the diameter is 50 centimeters. Well, we can see that it's increasing at 0.0127 centimeters per second.